Over the past few years, the stock market has been on an absolute tear, largely carried by 7 tech companies making massive moves in artificial intelligence. Investors are flooding money into these businesses, which now account for over a third of the entire S&P 500 index. The company pulling the most weight in this boom is Nvidia. They are a $4.5 trillion behemoth, and if you listen to the news, you'll hear the same thing repeated over and over. Nvidia makes the chips that fuel the AI revolution. But Nvidia doesn't actually manufacture anything. Like Apple, they are essentially chip designers. Their immense valuation comes from drawing the blueprints, figuring out how to map memory and process data. When it comes to physically creating the hardware, they rely on someone else entirely. All of those designs are handed off to a single physical choke point. The most desired hardware in the world, from the processor in your iPhone to Nvidia's top-tier AI GPUs, is manufactured by exactly one company, TSMC. TSMC stands for Taiwan Semiconductor. That geographic location is a serious problem, because U.S. intelligence believes Beijing is preparing its military forces for a potential invasion of Taiwan by 2027. We're already seeing specific landing ships and commercial ferries being built, capable of transporting armored vehicles across the strait. You have an entire trillion-dollar AI industry, and almost all of the world's most advanced processing power balancing precisely on one small island threatened by imminent global conflict. The obvious question is, why stay? If Taiwan is such a massive risk, why can't Nvidia and Apple simply take their blueprints and rent out a different manufacturing plant in Texas or Europe? To understand the physical barrier to entry, look at this diagram comparing a human hair to a 3-nanometer transistor. These companies are designing components that are roughly 3,000 to 4,000 times smaller than a single strand of hair. Hitting that microscopic scale requires an insane level of precision, which depends on lithography machines that cost nearly $400 million apiece. Only one company on Earth, ASML, even builds those machines. Even if a competitor gets their hands on the equipment, they run into a problem called yield loss. As this graphic shows, when another manufacturer like Samsung tries to match TSMC's volume, a huge portion of the hardware comes out defective. When you're making $30,000 GPUs at scale, a 20% failure rate destroys your profit margins. Nvidia actually learned this the hard way during the pandemic. They tried using Samsung's processors, but the yields were so poor they immediately routed their orders straight back to TSMC for the next generation. You cannot just swap them out. The exact physics of the technology and the severe cost of manufacturing errors mean there is no ready-to-go backup plan anywhere in the world. The U.S. government recognizes this vulnerability, which is why billions of dollars are flowing through the CHIPS Act to bring TSMC's production to American soil, specifically through massive construction projects in Arizona. But a chip fabrication plant is nothing like a traditional assembly line. These are highly restricted clean rooms where the air is filtered past operating room standards. A single stray speck of dust can destroy an entire wafer worth millions of dollars. Running those rooms requires ultra-specialized local supply chains for specific gases and chemicals, which simply don't exist in the U.S. right now. More importantly, there's a severe talent shortage. TSMC had to physically fly their own engineers in from Taiwan just to get the initial Arizona operations up and running. And even when those initial hurdles are cleared, there's a larger flaw. Looking at this timeline chart comparing global AI chip demand to U.S. manufacturing capacity, you can see a major gap. The American plants are only slated to produce older 4-nanometer technology, while Apple and Nvidia already require 3-nanometer tech and are rapidly moving toward 2-nanometer processors. Building the factories is only step one. Developing the human expertise, the material suppliers, and the precision tools to actually match Taiwan's output is a process that will take well over a decade. That leaves us completely locked in today. If the geopolitical situation escalates in Taiwan tomorrow, the Western tech sector has zero alternatives. Under a foreign occupation, TSMC would instantly cease to function. The fabrication plants require constant, daily global inputs, specialized high-end machinery parts, and proprietary software from the US. If those supply lines are cut, the factories become useless structures of metal and concrete. The situation is severe enough that the U.S. has developed extreme contingency plans. It's widely understood in Washington that America would rather remotely disable the manufacturing tools or evacuate the key engineers entirely than allow the cutting-edge technology to fall under Chinese control. This threat exists alongside an existing global supply chain crisis. Right now, China already controls over 90% of the world's rare earth refining. That gives them massive, unyielding leverage over the raw materials required for electric vehicle batteries and Western defense equipment. Annexing Taiwan would hand Beijing a global monopoly on advanced semiconductors to match their existing dominance in rare earths. This consolidation of power would permanently shift economic leverage away from the West, crippling the foundations of the modern tech economy. We treat the current AI boom like it exists entirely in the cloud, driven by pure software and algorithms. But beneath the trillion-dollar valuations, the entire system relies on highly fragile physical machines located on a single contested island.